A typical robotic system comprises of a manipulator linkage and effector, sensors, actuator, controller system, feedback system, and a computer interface. Let's discuss them one by one. First is the manipulator linkage. The manipulator is the basic work handling component of a robot. It consists of an arm and a wrist. It is made of a series of links and joints, in which links are defined as the rigid sections that make up the mechanism and joints are defined as the connection between two links. Next is the end effector. A end effector is a device attached to the manipulator which interacts with the environment to perform tasks. The end effector is expected to perform tasks normally performed by the palm and finger arrangement of the human arm. The next component of a robot is sensors. Robotic sensors are used to estimate a robot's condition and environment. These signals are passed to a controller to enable appropriate behavior. Sensors in robots are based on the functions of human sensory organs. Robots require extensive information about their environment in order to function effectively. Now let's understand some of the most common sensors used in a robotic system. First is the vision sensor. Vision sensor uses images captured by a camera to determine presence, orientation, and accuracy of parts. Tactical sensor is a device that measures information arising from physical interaction with its environment. Proximity sensing is the ability of a robot to tell when it is near an object or when something is near it. This sense keeps a robot from running into things. It can also be used to measure the distance from a robot to some object. The range sensor combines an ultrasonic sensor to detect objects from approximately 5 to 255 cm and an optical sensor to detect objects closer than 5 cm. Next is a velocity sensor. A velocity or speed sensor measures consecutive position measurements at known intervals and computes the time rate of change in the position values. And last but not the least, voice or sound sensor. A sound sensor may be added to give the initial direction and start to the robot. By recognizing the frequency of sounds like claps, it will move to different directions. The next component of a robot would be actuator. Actuators are used in order to produce mechanical movement in robot. Actuators are in fact the muscles of robots. There are many types of actuators available depending on the load involved. And by the term load, we means many factors including force, torque, speed of operation, accuracy, precision, and power consumption. We have electric motors for rotary motion, linear actuators for linear motion, which can be pneumatic, hydraulic, or electric, elastic actuators for advanced interaction with the environment, muscle wire having shape memory alloy to lift heavy objects, piezo motors for minimalist design and ability to exert a large displacement with a low driving voltage, electroactive polymers for shape shifting properties in response to electrical stimuli, and lastly, elastic nanotubes for nanorobotic applications. The next component of a robot is feedback mechanism. It is a device used within a robotic system for measuring a specific variable. There are mainly two types of feedback: positive and negative feedback. In positive feedback mechanism, the response is transmitted across the same direction of the stimuli. In negative feedback mechanism, the response is transmitted across the opposite direction. And lastly, we have the computer interface of a robot, which involves the GUI or graphical user interface that allows the user to command and interact with the robot itself.